We are now ready to run the simulation in all the scenarios to get our results. On the top bar menu, click Scenarios and click Manage Scenarios. In the Results field, change Uncollected to Collect. And change the simulation duration to 0.5. And then click OK. So the simulation will run for at least a minute or two, so please wait. When the close button appears, that means our simulation was completed, so click close to close the window. Now let us analyze the results. So click Results on the top bar menu and select Compare Results. In the window that opens, you will see that the items we selected in Global Statistics earlier is now showing under Global Statistics. Expand HTTP under Global Statistics and click Traffic Sent. So we're going to view all the statistics in Assist mode. The Assist mode will show the exact results of the selected statistics. So click Show button to see the pop-up graph, and then click Traffic Received, and then click Show to see better detail on the graph. And now let us compare it together. You may notice that our scenario name indicated the speed of data transmission and the number of workstations. So the blue graph represents the 10 Mbps speed with 15 workstations. The red color represents the 10 Mbps speed with 30 workstations, and the green graph represents the 100 Mbps speed with 30 computers. The statistics showed the sum total of HTTP traffic received and sent by all workstations in our Ethernet network. So as expected, the red and green graph shows twice as much traffic compared to the blue one. Obviously, because the first scenario has only 15 computers, while the second and third scenario has 30 computers that requested HTTP application services. You may notice that the traffic received on the left side and the HTTP traffic sent on the right side are identical. That is because the HTTP traffic that our server received were all delivered. And comparing our 10 Mbps 30 scenario with 100 Mbps 30 scenario, do you know why the traffic received and sent of both scenarios is almost identical? Well, the 100 Mbps transmission speed is 10 times greater than a 10 Mbps link. Still, the same number of workstations and the same amount of packets were forwarded by the switch. That is why there's not much difference of the traffic received and sent of both scenarios. Now close and delete both graphs. And expand the Ethernet statistics and click Delay. Then click Show button to see more details. First, let us compare the 10 Mbps with 15 workstations and the 10 Mbps with 30 workstation scenario. You can see that the 10 Mbps 15 scenario has a little bit lesser delay compared to the 10 Mbps 30 scenario. The impact of the Ethernet delay between the two scenarios was caused by doubled number of application traffic from a doubled number of computers that sends and receive packets into the local area network. So imagine a single slow-paced lane where 30 cars are trying to pass at the same time. Comparing it with the 15 cars that are trying to pass at the same time at the same speed, we will know right away the 15 cars would not experience much delay compared to the 30 cars on the same speed, right? Now let us compare the 10 Mbps with 30 workstation scenario between the 100 Mbps with 30 workstation scenario. You can see that the 100 Mbps with 30 workstations has consistent zero delay, while the 10 Mbps with 30 workstation has like almost 4 milliseconds of delay. Well, with fast Ethernet, the transmission speed is 10 times faster than a 10 Mbps. So imagine a freeway with several lanes and much faster speed. That means 30 cars can easily pass through compared with a slower speed, right? So in this laboratory, we are able to find out that expanding the network by doubling the number of workstations increases the amount of application traffic. And so with the same transmission speed of 10 Mbps, the increased traffic has caused greater delay in the delivery of packets. However, if we upgrade the bit rate to fast Ethernet 100 Mbps, then the expanded network's transmission of packet will experience a 0 millisecond of delay. So we've now completed our laboratory 4. Hopefully you're able to gain an understanding about some basic impacts of Ethernet delay in local area network. Also, I hope that the laboratory has provided some basic tips when planning and designing a network. Please check embrace.csumb.edu for more tutorials. Thank you for watching.